Hi everyone, my name is Isaac Eskin and I welcome you to today's lesson. Now in today's video I'm going to show you step by step how to derive the reduction formula for integral of cos of x to the power n dx. Now notice that the integral of cos of x to the power n dx can also be written as the integral of cos of x to the power n minus 1 multiplying cos of x. Of course, this is equal to this because using the law of indices, we know that the bases are the same. And if the bases are the same, we add the exponent, right? Of course, this has exponent 1. So n minus 1 plus 1 definitely will give you this to the power n. So this is equal to this. And I'm going to use this to derive the reduction formula. Now here, what I will do is I'm going to use the integration by part to solve this integral. So I will let u be equal to cos to the power n minus 1 of x, and then I will let dv to be equal to cos of x. And don't forget the integration for the integration by part formula, which says the integral of u dv is equal to uv minus the integral of v du. So this is what I'm going to use to derive the reduction formula. Now from this, I'm going to find du dx. I'm going to differentiate u with respect to x. Now look at this. This looks like a composite function, right? So I'll bring n minus 1 down, multiplying cos n minus 2, right? Because I'll subtract 1 from the top. That'll give me n minus 2 of x. And don't forget, because it's a composite function, we use the chain rule. So now I need to differentiate the cos function as a whole, and that is going to give me minus sine of x. And of course, this is the same as I'll put the negative out. So minus n minus 1 into bracket cos to the power n minus 2 of x multiplying sine of x. Then with the dv, what I'm going to do is that, let me do it here. So with the dv equals cos x, I want to find v. So I'll integrate both sides so that here I'll have v. Of course, when you integrate, let me write it well. When you integrate cos x, you get sine x. At this point, don't bring your constant of integration. All right, so now that I know my u, I know my du. Of course, this is du over dx. So if I cross multiply, I have my du. And then now that I also have my v, I will plug these into the integration by part formula. So my integral of cos to the power n of x dx, that's what we are trying to derive. Now I'm going to plug this in. So I'm going to have, of course, this is u and then v. What is u? U is cos to the power n minus 1 of x. Then what is v? V is sine x. Minus the integral of what is v? V is sine x. Then look at this. This is du. So from du dx, I can make du the subject so that I will get, this will be minus n minus 1. Oh, sorry. That should be, so sine x into bracket negative then n minus 1. Then we have cos to the power n minus 2 of x. Then we have sine x dx, because from du dx I just cross multiply, so the dx multiplies everything here. Now notice something, we have sine x here, we have sine x here, and they are multiplying. So I'm going to have cos to the power n minus 1 of x sine x minus the integral. When I multiply sine x, I'm going to get sine squared x. Then we have n minus 1, then cos n minus 2 of x. Then we bring out dx. Now notice that we have a trig identity. There's a trig identity. There's a trig identity that says that sine squared x plus cos squared x is equal to 1, right? So this implies that sine squared x is equal to 1 minus cos squared x. So in place of sine squared x here, I'm going to substitute that by 1 minus cos squared x. So finally, I'll be having cos to the power n minus 1 of x multiplying sine x minus this one. So in fact, let me pull minus n minus 1 this out, because it's just a constant. So if I pull out, notice that there is negative here. If it comes out, this, it will meet this negative, and then we have positive n minus. So let me write it well. So what I'm doing is that I'm pulling this constant n minus 1 out. It already has a negative in front. So if it comes out to meet this negative, we have positive. So plus n minus 1. Then the integral of cos n minus 2 of x. Then in place of the sine squared x, I'm going to put this. I'm going to substitute it there. So I have 1 minus cos squared x. Right? Of course, dx. And what I'm going to do is that I have cos to the power n minus 1 of x multiplying sine x plus n minus 1. Now, this integral, so look at something. I'm going to multiply this integral. I'm going to use this to expand that. So the integral of cos n minus 2 to the power n minus 2 of x multiplying 1 will be the integral. Let me put this in a square bracket. The integral of cos n minus 2 of x, right? Then minus the same integral of cos n minus 2 multiplying this cos squared x. Notice that the bases are the same, so we will add the exponent, and when we add the exponent, n minus 2 plus 2 will just be n. So we have the integral of cos to the power n of x. Can you see? Of course, I can introduce dx for each side. So now we have this, and this, what we have in the square bracket, is being multiplied by n minus 1. So I'm going to expand that one too with the n minus 1. So we have cos to the power n minus 1 of x multiplying sine x. That's what we have. Then plus, so what I'm doing is that I'm going to expand this by the n minus 1. So n minus 1 will multiply this side, and n minus 1 will also multiply the other side. So we are going to have n minus 1, then the integral of, so n minus 1, then the integral of cos to the power n minus 2 of x dx. Right, that is for the first one. Now this one, notice that there is negative here, so it will affect this. So we are going to have minus, then n minus 1, then the integral of cos to the power n of x dx. Right, don't forget that this is what we are solving. We are solving cos to the power n of x dx. This is actually what we are solving. Now you can see that this side and then this side, they are having like terms. So I'm going to group them. So I'm going to have the integral of cos to the power n of x dx. I will move this side, but I'll move this one to the other side, and it will become plus into bracket n minus 1, then the integral of cos n of x. Right, then you bring your dx, and this is equal to cos n minus 1 of x multiplying sine x. Right, then plus n minus 1 also multiplying the integral of cos to the power n minus 2 of x dx. So here I'm going to expand this bracket that we have here, the n minus 1 multiplying this. So I'm going to have cos to the power n of x dx plus, here n multiplies this integral. So we have n integral of cos to the power n of x dx, and the negative one also multiplies this integral, will give us minus integral of cos to the power n of x dx, and this is equal to the right hand side, cos to the power n minus 1 of x sine x plus n minus 1, the integral of cos n minus 2 of x dx. Now notice that this cancels this, right? They are the same. So this minus this, they cancel. So we are left with n integral of cos to the power n of x dx. And this is equal to the right hand side. Integral of cos n minus 2 of x dx. Now notice that this is the actual thing. When we began, look, this is what we are trying to find the formula for. We are trying to derive the formula for this integral, right? And where we have gotten to, we have that here. So the only thing we need to do is to divide through by n. We divide through by n, so that we have the integral of cos to the power n of x dx, which is what we are actually solving, what we are looking for. This is equal to, now look, I'm going to have 1 on n cos to the power n minus 1 of x, then sine x, right? And then plus, we have n minus 1 into bracket over n, then integral of cos n minus 2 of x dx, right? So clearly this is the reduction formula for cos. And this is what we are going to use to solve most of the questions in integration that involves the powers of cos. For example, we can have the integral of cos to the power 3 of x. So we can ask you to compute this particular integral. So with this, you can see that n is 3, right? The power is 3. So it depends on the question. For some examiners or for some lecturers, they will tell you that derive the reduction formula and then use it to compute this integral. But if you are not asked to derive the formula, then you just need to put this in your head so that you can use this to find this integral. So using this reduction formula, I'm going to calculate or compute this integral. Note that our n is 3 here. So I'm going to have 1 on 3. Then cos, now we have n minus 1 and n is 3. So 3 minus 1 is 2. So cos squared x sine x plus, now we have n minus 1, of which n is 3. So 3 minus 1 is 2 over n, which is 3. Then the integral of cos n minus 2, our n is 3. And 3 minus 2 is just 1. So cos x dx. Now notice that I don't need to do anything to this side. But for here, there is an integral here which I need to compute. So we are going to have 1 over 3 cos squared x sine x plus 2 on 3. Now what is the integral of cos x? By now you should know the integrals of the trig functions. So when you integrate cos x with respect to x, you are going to get sine x plus your constant of integration c. So this will be the integral of cos to the power 3 of x using the reduction formula. Thank you.